Assalamualaikum everyone, we are from Group 10. Today I'm excited to present synopsis of Foodbear. Foodbear, an innovative and user-friendly online food ordering platform. Foodbear aims to simplify the way users discover meal, place order and track deliveries, all in just a few clicks or taps. It also provides a dedicated system for restaurant owners to manage the business effectively. Let's go through the main features of Foodbear. First, it offers a user-friendly interface designed for quick and easy navigation, even for first-time users. Next, we have a restaurant and admin panel giving food vendors tools to update menus, manage order, and track users. Real-time order tracking lets customers monitor their food from the kitchen to their doorstep. The secure payment system supports various options and uses encryption to protect transactions. We are also implemented user verification and profile management for secure access. Lastly, the platform includes a rating and review system, allowing customers to share their feedback and help restaurants improve. Foodbear is built using modern web technologies to ensure great performance and scalability. The front end is developed with React JavaScript, making the interface fast, dynamic, and responsive. The backend runs on JavaScript, which efficiently manages API requests and data communication. We use a cloud-based database to store user and restaurant data securely, with high availability. For security, we implement SSL encryption and integrate secure payment gateways to keep user data and financial information safe. The project follows the agile development methodology. This means we work in short iterative cycle, constantly gathering feedback, testing new features, and making improvement along the way. Agile allows us to adapt to user needs quickly and make the product better with every release. So, why choose Foodbear? Foodbear is more than just a food ordering app. It is a scalable solution that enhances the digital experience for both customer and restaurant owner. It supports local business, ensures user safety, and makes the ordering process more efficient. By combining usability performance and strong security, Foodbear stands out as a modern platform ready to grow with its users.
The cost estimation for our project using the bottom-up estimation technique. This method involves breaking the entire project into smaller, detailed components. Then, we estimate the cost for each part based on time, effort, and required resources. This gives us a clearer and more accurate total cost. First, the project manager is estimated for 4 months at 5,000 ringgit per month, giving us a total of 20,000 ringgit. Next, we have 2 software developers working for 4 months. Each developer costs 4,000 ringgit per month, so each total for both is 32,000 ringgit. Then, we include a UI or UX designer for 2 months at 3,000 ringgit per month. That total 6,000 ringgit. For our backend, we are using Firebase which includes authentication and database service. This is a one-time cost of 1,200 ringgit. We also need web hosting and domain, which is estimated at 100 ringgit per month for 12 months. That gives us another 1,200 ringgit. Testing and quality assurance, which will be done manually, is scheduled for one month for 3,000 ringgit. We also allocate 2,500 ringgit for software license and tools that might be required during development. Finally, to prepare for unexpected expenses, we include 4,100 ringgit as miscellaneous or contingency cost which is around 10% of the total. So, when we add everything up, the total estimated project costs come to 70,000 ringgit. This estimation ensures we have a well-planned budget to manage our project effectively from start to finish.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Furadin Azam. Number metric 079598. I will explain about the cost budgeting of our project. This is the table of the activity list, and there are 10 activities. The first one is requirement gathering and planning. First, we conduct the stakeholder meeting, and we define the future, and we estimate the cost and scope of the project, and we set the project timeline. And the second one is we do some project meeting and the cost review. We do some regular stand-up and sprint planning and budget update session to keep the budget, to maintain the budget is not above, is not over budget. And then third is UI UX design. We design for wireframe, prototype, and user flow by get some feedback from the stakeholder. And number four is back-end development. We set up servers, database, API, and handle the business logic. Number five is front-end development. We build user interface for customer by the end restaurant. Number six is testing QA, testing quality assurance. We have to do some manual and automated testing, and we also do a bug checking to check the bug that have from the app, and we perform performance testing and load testing. And number seven is tooling and license setup. We subscribe to development tool and testing the platform and testing the CI/CD system. And number eight is deployment. We publish the app to the App Store, and we configure the backend service and set up the DNS or the domain of the project. Number nine is maintenance and feedback loop. We do some bug fixing using the fixing tool we have, and we gather some user feedback of the app, and we do the app updates and and do performance monitoring. And number 10 is contingency and risk reserve. We do some budget buffer for unexpected issue, technical delay, or scope change. And the next one is cost distribution overview. There are three points. The first point is phase-based allocation. Costs are divided across key phases like planning, design, development, testing, deployment, and support. The second point is contingency reserve. 10% of the budget is set aside for unexpected expense. It's like emergency funds. And the third one is milestone-based funding. Funds are released based on the completed deliverable and project milestone. Like when a project milestone reach, fund will be released based on the milestone project. And as you can see, this is our cost budgeting timeline. Like this is the amount that we use at the certain phase. Like the first one is phase is planning, 8,000 ringgit, and UI UX design is 6,000 ringgit, and front end and back end development 40,000 ringgit combined, and testing and quality assurance is 3,000 ringgit, and deployment is 2,000 ringgit. Tool and license is 3,700 ringgit, and contingency reserve is 400 4,100 ringgit, and miscellaneous is 3,200 ringgit, and the total is 70,000 ringgit for the completing the project.
We move on to cost control. Cost control is the process of monitoring project performance to ensure that it stays within the approved budget and schedule. The importance of using cost control, it helps identify variances from the plans. Also, using cost control, we can do corrective actions in time to keep the project on track. To do cost control, we need to calculate EVM items. EVM stands for Estimated Value Management. The item is Earned Value, Cost Variance, Schedule Variance, Cost Performance Index, Schedule Performance Index, Estimate at Completion, and Variance at Completion. To calculate the value for the EVM items, firstly, let's assume that we are on the third month. So our planned work at this month should be 60%, and our actual work completion is at the 40%, and budget at the completion date should be around 70,000 ringgit, and the actual cost right now is 45,000 ringgit. To calculate the earned value, we multiply 40% with the budget at completion. We will get 28,000 ringgit. For cost variance, earned value minus the actual cost, we will get 70,000 ringgit. For schedule variance, earned value minus the planned value, which is negative 40,000 ringgit. For cost performance index, earned value divided by actual cost, we will get around 0.622. For schedule performance index, earned value divided by planned value, we will get 0.667. For estimate at completion, budget at completion divided by CPI, cost performance index from before, substitute that into the equation, and we will get 112,544 ringgit. And for variance at completion, budget at completion minus with estimate at completion from before, we will get negative 42,542 ringgit. After we have done all the calculation, we should put all the value inside the table for a better view. And all this value can decide our current budget performance. Forecasting metrics are used to predict future project performance based on current data. They help project managers to anticipate costs and timelines. The following metrics are considered forecasting metrics. From the EVM items, we have estimate at completion, EAC. It can predict the total cost of the project at completion based on our current performance. And variance at completion, VAC. It indicates the expected budget overrun or underrun at project completion. From these forecasting metrics, we can predict how much budget will be used by the end of the project. We look at summary of EVM metrics. Firstly, we have cost performance index, which is 0.622, that is lower than 1, which means we are over budget. And then schedule performance index, SPI, our value at 0.667, which means the project currently is behind schedule. And estimate at completion, we estimate that we will use around 112,542 ringgit by the end of the project. And the variance at the completion means that how much the difference between the planned budget to be used versus the actual budget is going to be used at the end of the project. If we didn't take any corrective actions, the project will exceed the budget by 42,542 ringgit.
Based on the current cost performance, we propose 3 key strategies to improve efficiencies and reduce expenses. First, we recommend eliminating non-essential expenditures. This includes replacing premium software with open source alternatives and reducing our reliance on costly external QA services by introducing automated testing suites. Second, we aim to optimize our development resources. This can be done by refactoring and reusing existing code components by implementing version control along with CI/CD tools to minimize rework and enhance productivity. Third, we want to enhance overall team efficiencies. Mid-sprint reviews will realign goals and prevent scope creep, while daily agile stand-ups will improve internal coordination and communication. Post-correction forecast. If these measures are applied and we successfully reduce our actual cost to RM 40,000, the new cost performance index or CPI will increase to 0.70. While this reflects an improvement, further adjustments will still be necessary to reach our ideal cost efficiencies. In conclusion, the Foodbear project offers a promising digital solution to improve campus food service efficiency despite current setbacks evidenced by a low CPI of 0.622 and SPI of 0.667. The project remains viable with corrective action. Recovery depends on implementing cost-saving measures, adopting affordable technology, automating QA, and enhancing development through agile methods. Improved communication and regular sprint reviews can help realign the project. With flexible scope management and proactive use of performance insights, Foodbear still holds strong potential for success and impact.